Hello scientists, for today's demo I will need a safety apron, my safety goggles, and some things that you have in your laboratory kit, including a beaker with a little water, your test tube rack, a plastic test tube with the cover, mass balance, which you remove the cover from. And then today I'll also be using a balloon and something called Alka-Seltzer, which you may have at home right in your medicine cabinet. And if you take a look at this next advertisement, you'll know exactly how it behaves when it's mixed with water.
You worked too hard, you ate too much, the cheesecake made you greedy. Let your aching head and stomach hear this message from old Speedy. Alka-Seltzer, plop, plop, fizz, fizz, oh, what a relief it is. Plop, plop, fizz, fizz, oh, what a relief it is. Those Speedy bubbles relieve your upset stomach and headache fast. For acid indigestion alone, Alka-Seltzer Gold. Oh, what a relief it is. What a relief.
So now Dr. Campbell Malone is adding water to her test tube, and then she's going to break the piece of Alka-Seltzer up into pieces and place it into the balloon. We use a balloon in this system because we want to be able to find the total mass before we mix it, and then be able to mix the Alka-Seltzer into the water in a contained system. So here she is zeroing out or tarring the beaker so that it doesn't factor into our mass. And then she's going to place the Alka-Seltzer in the balloon and the test tube with the water in the beaker and check the mass right now. Now what Dr. Campbell Malone is going to do is she's going to attach the balloon securely onto the top of the test tube with a rubber band. This will allow her to make it a sealed container and squish the Alka-Seltzer into the water. So let's wait to see. She's going to do that in a moment. And you can see the Alka-Seltzer immediately hitting the water and creating a fizz. Notice that what happens to the rubber balloon as the gas is being created. If you were there, you would hear the fizzing of the Alka-Seltzer as it dissolves into the water. Then what she's going to do is she's going to take the cap and the entire contents of the balloon and the test tube and the water and the Alka-Seltzer, and she's going to remass it.
So there you have it, scientists. You have witnessed a demonstration of a mixture of a solid with a liquid that produces a gas, and you now have two measurements, the original dry Alka-Seltzer and all of the other ingredients, and a measurement of the mass of the mixture of Alka-Seltzer and water producing gas. That'll tell you how much mass is lost or gained when a chemical reaction occurs. The last measurement that you have is of the balloon removed from the top of the test tube, and that will tell you what about this whole setup. What is the mass that was measured the last time we measured mass, and how does it compare to the other two measurements? It's a little mystery for you, and I know you can solve it. Take care.